Before we start into writing NobleGas configurations, which is even a more shorthand notation, I want to review writing electron configurations first. So let's take a look at aluminum. All right, so here you have aluminum right here. All right, so the electron configuration for aluminum would be 1s2, 2s2, 2p6, 3s2, and 3p1. That would be the NobleGas configuration for aluminum. If we write one more and we take a look at the NobleGas configuration for fluorine, the electron configuration for fluorine. Fluorine's electron configuration will be 1s2, 2s2, and 2p5. That is the electron configuration for fluorine. So the NobleGas configuration is a shorthand of electron configuration. So one of the things that we discussed earlier is that the elements in group 8, main group 8, they are special because they have a full valence shell. So helium is full or stable with 2, while all others are stable with 8. And so the metals will lose electrons and the nonmetals will gain electrons to look like the noble gases. So first, let's write the NobleGas configurations, the electron configuration for helium and for beryllium. Let's do those two first. So helium has an electron configuration of 1s2. Beryllium has an electron configuration of 1s2, 2s2. Now, when you compare those two electron configurations, what do they have in common? All right, so you see that they have the 1s2 in common. So when you write the NobleGas configuration for beryllium, all you have to do is, first you'll take helium because that's the noble gas, put it in brackets, and then write everything that is different. So then it becomes helium and then 2s2. All right? And so when writing NobleGas configurations, always use a noble gas that comes before the element. So let's see. What noble gas would you use if you were going to write the NobleGas configuration for phosphorus? It would be neon. What noble gas would you use if you're going to write the NobleGas configuration for strontium? It would be krypton, because once again, we use a noble gas that comes immediately before the element. So let's take a look, and I am going to all right, let's take a look and write the NobleGas configuration for chlorine. So first I'm going to do both the NobleGas and chlorine because I want you to see what they have in common and how they are different. So taking a look at neon. Neon's electron configuration is 1s2, 2s2, 2p6. And then chlorine's electron configuration is 1s2, 2s2, 2p6, 3s2, and 3p5. Again, why did I choose the NobleGas why did I choose the NobleGas neon when about to write the NobleGas configuration? So why did I choose neon for the NobleGas instead of argon or instead of krypton? When writing the NobleGas configuration, why am I using neon instead of argon, helium, or krypton? The reason is that you always choose the NobleGas that comes immediately before the element. So yes, helium comes before chlorine, but neon is immediately before it. Argon is not an option because it comes after chlorine. Krypton is not an option because it comes after chlorine. So when you look at these two configurations, what do they have in common? They have all the way through 2p6 in common. So when you go to write the NobleGas configuration for chlorine, it would be neon in brackets, and then everything that is different. So it becomes 3s2 and 3p5. So now let's take a look at sodium. Let's write the NobleGas configuration for sodium. What NobleGas comes immediately before neon? Excuse me. What NobleGas? I just told you the answer. What NobleGas comes immediately before sodium? You're correct. It is neon. So we put neon in brackets, and then we pick up where neon ends. So right here, this would take us all the way through 2p6, and then we simply start right here with 3s1 because sodium is in the third period. It's an S group element, and it's in the first box. Let's try another one. Let's take a look at carbon. What NobleGas comes immediately before carbon? Helium. So now we write everything that comes after helium. So helium takes care of our 1s2. So we'll pick up with 2s2. That is a 2. 2s2. And then again, we're going to carbon, and that becomes 2p2. That is the NobleGas configuration for carbon. All right, so now let's write the NobleGas configuration for iron. Here's iron. So what NobleGas comes before iron? The NobleGas that comes immediately before iron is argon. So we'll put argon in brackets and then write everything after argon. Now remember, this is our D sublevel, so with the D sublevel, it's going to be N-1. So it's going to be 3D. And let's count to iron. 1, 2, 3, 4, 5, 6. 3D6, and then 4s2. That's a lot faster than having to write out the whole thing for iron. Let's try another one. Let's take a look at strontium. Now, if we were going to write the electron configuration for strontium, we do 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, and then 5s2. But with NobleGas configuration, you don't have to write all that. You will put what NobleGas comes immediately before strontium. It would be krypton, so we're going to put krypton in brackets, and then pick up where krypton leaves off, and that would be 5s2. Last one, let's write the NobleGas configuration for arsenic. What NobleGas comes immediately before arsenic? The noble gas is argon. So we'll put argon in brackets, and we will do everything after argon. So we stop here. This is argon, and pick up here with 3D10, 4S2, and 4P3. All right? So remember, it is important that when you write these electron configurations, that you write them in order by principal quantum number. Yes, I know this is 4S, then 3D, but we have to make sure we write them in order of principal quantum number. That is the end of that lesson. See you back on how to identify valence electrons.